Hello, Keith Rucker here at VintageMachinery.org. Well guys, today we're going to get our milling machine, our horizontal milling machine. This is a Kearney Trecker 2H horizontal mill. And we got a job coming up where I basically am needing to do some cylindrical grinding. And since I don't have a cylindrical grinder, and this is kind of an unusual setup, I'm not even sure that I could really do this on a cylindrical grinder. But we're basically going to use this machine like a cylindrical grinder. So in a previous episode, I made a little fixture here to mount a tool post grinder onto the overarm supports on the mill here. So I've got a grinding wheel here that's pretty much ready to go. What I got now to do is I need to get my part that I've got, which is the transmission out of a Landis Surface Grinder that does the auto feed on it. And this got a shaft on it that's worn where a pulley spun on it. It's worn where it's not the same diameter all the way down. We need to get it to a consistent diameter. Because the pulley has also been wallered out on the inside, it's not uniform. I'm not really concerned about what diameter that is because I'm going to have to make a bushing to go into the pulley. I'm going to have to bore and bush the pulley, and I can basically make the bore and the pulley match whatever we end up over here. So my goal here is just to get it cleaned up to a uniform diameter, and then we'll make the other part fit. So I've got my mill prepped up here. One thing I will note is that the part that I'm putting on here, at least the back side of it, is so wide that I wasn't going to have any room to clamp to the table. My table just really wasn't wide enough for this. So I just took a piece of steel here. This is probably some, I don't know, 5/8 inch, 3/4 inch thick steel plate or something like that. And I drilled 3 holes in it, bolted it down to the table. 2 of the holes are tapped 1/2 inch 13, and I strategically placed that where I can put some clamping rods in there and clamp the back side of this down, because without that, you can see my holes are pretty much right out here at the edge of the table where my studs need to go down. So we're just going to basically just, it got threaded right into this piece. And it's just an adapter, again, to make my table a little bit bigger than what I've got. I'm making my machine, adapting my machine for the job. So let's go get the transmission loaded up. We're going to put it on the engine hoist and bring it over here and get it onto the mill. I've got my part slinged up over here now, hooked on this end. This strap really can't move any farther this way just because of the casting here. On this side, my strap, it could theoretically kind of move up underneath this, and because I want to pick it up on the outside edges, I took just a piece of metal here and put it in here. That's basically to keep that strap from going past this point right here. So we should have a good, safe lift here. And I'm just going to use my engine hoist to carefully pick it up. And that's nice, staying nice and level. And now we're going to roll it over to the mill. I have to raise it up just a little bit here. I'm trying to get this thing kind of roughly positioned. I got some blocks just to temporarily put this up here. I want my piece on the back to be kind of back about as far as I can go, just to give me more room on the front. This is close. I'm going to probably have to fine tune it, but we're going to let it down real easy right here. All right. Let's go ahead and get these slings off, and we can fine position this thing. I'm working on getting this piece mounted here on the machine now, and we got it sitting on the block back here in the back that I made. I've already got one stud in the back and just loosely clamped back here. Now back behind this clamp on the top, I've just got it's a planer jack. It's like a little machinist jack, something like this, but a taller one, and that gave me the height I needed to block it up on the back pretty easily. Like I said, that's just loosely on here. We're also going to clamp it on the front and over this front planer jack here in the front, which is a little lopsided on right now. We'll straighten that up here in just a minute. First thing I need to do though is I need to get this thing kind of square, and I'm going to be indicating it in here in a minute to fine tune it, but just to kind of make my life easy, this is a machine surface on the back of this, and we're going to be indicating off of that to get this thing oriented like that. So we'll run an indicator up and down its face. But before I do, I'm just going to put a square on here, and just shining behind it with a flashlight, I can tell that this needs to come down in the front a little bit. So let me adjust that planer jack up there, and we're going to lower it down and get it close. So it needs to come down. I'll put my wrench on here and take it down just a little bit. And I got that now where it looks pretty uniform up and down this thing. So again, we're going to come in here with the indicator, and we'll fine tune that, but the square should get me real close to a starting point. Next thing I want to do is go ahead and get this thing indicated in so that it's running square in two directions. So basically we want to make sure it's not running uphill or downhill in this direction. And we've already put the square on this back side, so we should be really close on that one. The other one we want to do is make sure that it's not running side to side in any direction. We want it to be square. And for that, we're going to use the top of this surface here. We're going to sweep an indicator back and forth across here. The only other real area there is, it could be tilted up and down because it's just sitting on this plate down here. I don't know if that's a machine surface down there or not. That really doesn't matter though, because if it's twisted in this direction, that's the direction that the shaft is in. So you're basically twisting it in the rotational direction of the shaft. So that's not important at all. Even if it is off running uphill or downhill in this direction, it does not matter. So we're going to now come in here. I took my grinding fixture off just so I could get an indicator in here and have a little bit more room to work for this indicating. We can put that back on real easily. And I got an indicator set up. We're going to sweep the top first and see where we're at. So right now I've just kind of eyeballed it. I just kind of looked down the side of my casting up here and kind of compared that to the edge of my table and just eyeballing it in and out, and we'll see how close we are. So this is a 1/2 thousandths indicator that I got on here. So each line on there is a 1/2 thou. The big lines are 1/1000. If I can get this thing square within probably about 1 to 2 thousandths, I'm going to be happy. One thing I will note is this back surface back here, while it is machined, it is somewhat of a rough machine. I can actually see the mill marks in here. So I'm going to expect that needle to be jumping around a little bit as we go, but kind of on average it should stay the same. So let's just go ahead and sweep down through here. I can't even see the indicator right now. You guys can. Let's get down to the end and we'll see where we're at. All right, let's see where we're at. So we're off about 5 thou right now. So that's probably not too bad considering that I just eyeballed this thing in. So let me get a dead blow hammer and we're going to tap the end down here and move it around to try to get it probably back to 0 for now. It's going to take a couple of times to adjust this thing where it needs to be. All right, that's the right direction. All right, I'm going to take it back to the other side and we'll sweep it again. So let me All right, so we're back on 0. That's good. That I didn't adjust the indicator at all. And one thing I'll note is I'm clamped on this corner right here. And so this is kind of serving as the pivot point. When I tap that front, it's pivoting pretty much right below this clamp. At least that in theory, that's what should be going on. So I did that on purpose so that when I'm tapping it out here and I bring it back in, it should not change this end, and as you can see it did not. So now let's sweep back down the other direction. And whoops, bump the camera. And we are right on 2/1000ths right now. And I'm going to tap it again just because I can. That's probably good enough for what we're doing here. But if we can get it a little bit better, let's shoot for it. All right, go back, sweep it again. All right, we're back to 0 again. One thing I'll note too is that when you move this thing, you kind of load that indicator. So I wanted to make sure I was loading it back in the direction we were moving, because just the load on the indicator moving one direction to the other will make a difference. But it's repeating, so that's good news. Let's bring it back down one more time. All right, that's 1/1000ths, maybe just a shade over. I'm good with that. We're going to leave well enough alone, and I'm going to set up and we'll indicate off of this other edge over here now. And I'll probably go back and double check that when we do that. So next we want to adjust our angle in this direction, and we're going to again use this machine surface back here to indicate off of. Now the first thing I want to do is I want to look, so where's my pivot point? Where am I pivoting at when I make adjustments? So we'll be raising and lowering the end down here, and I've got a machinist jack or planer jack that I can screw up or down to make adjustments. So my pivot point is basically this bottom edge down here. That's where it's going to be pivoting from. I want to set my 0 at the pivot point so that when I go to the top extreme, I can just bring the indicator back to 0, and I should be pretty darn close to where I need to be. If I start up here and move down, it gets really difficult to make your adjustments. So anyway, we're going to do that. So I got my indicator in here. Let's go ahead and load it up and take it to 0. And sorry to put my head in front of you, but I want to look around there. That is on 0. It may not look that way on your screen because you're looking a little bit at an angle. Let's just lower our table down and see what happens. It's dropping off. I would have thought that square would have gotten it closer than that. All right, we've moved a good bit. I'm just going to go ahead and make an adjustment here. All right, I got my wrench here, and ooh. All right, guys, I had to make a little modification to my setup. We were having some issues over here. When I started moving the front around, the jack that I was using, this little planer jack, it's a real nice Armstrong, heavy duty, but the issue that I was having is it has this swivel top on it. And this is made, you know, just to kind of adjust to whatever surface you're going up against. And the problem I was having was when I was moving this thing around, it was just kind of flipping over, and it was not as strong as a setup as I needed once I kind of got it out of alignment straight up and down. So I changed plans and I went to a little bit, it's a smaller jack. It's still plenty strong enough to do what we're doing. This is a Starrett, and this is just like it, but it's got this little adapter that just fits on the bottom here. That's got a little V in it, which is great for going up against round stock. So basically I got this thing in here upside down. I've got one, this one here also has a swivel foot on it, but I've got one in here that's just got it's a solid, it's a kind of a rounded over piece that doesn't swivel. and I put a block of metal up here under it that has a hole in it, so that's kind of serving as my swivel now. It can swivel in that hole, but it's a lot more rigid setup, and I think this is going to work out a little bit better for me. So I've already come back over here and checked the tram on the top and got it fine-tuned back in. I didn't show that on video. We're going to come back in now and sweep this face here and actually get it set where it needs to be. I'm going to re-zero this, and I came back in here with the square and I re-squared this just manually with the square, similar to what we did before. And I think I figured out what's going on with my square, why my square wasn't giving us a super true reading that first time. This piece of metal that I'm bolted up on is not a perfectly flat, it's just a piece of hot rolled steel basically. So it's not necessarily got a surface that is parallel to the table, but I just use it to kind of get me in the ballpark again. I was a little bit more careful this time. Let's sweep it one more time and see where it's at this time, and then we'll make our adjustments from there. It's probably going to be similar to what we had last time. Let's drop the table down, and we're dropping a little bit as we go. Doesn't look like it's dropping quite as bad as last time. All right, I'm going to make my adjustment right here. So I'm going to come in here. I got a wrench, and we'll raise or lower this and see what happens. So see, I think I need to go up. Yeah, loosen this clamp up just a little bit. All right, so that's back to zero, close to it anyway. Let's bring the table up and we'll sweep it again and fine adjust it this time. All right, let me get the indicator loaded in the direction we're going. I'm going to re-zero this and let's go for a ride. I tried doing this to start with the rapids, but the vibration in the machine was causing my indicator to shake around too much, so I just decided to do it manually. You know, that's out a half thou. I think we're going to clamp this thing down and roll with it. That's a half a thousandths over about, what is that, about 8 inches or so? Yeah, about 8 inches. So, I mean, I think that's going to be plenty square to get that shaft to the same diameter down there. So, I think we are ready to start grinding. I've got everything set up now. So, again, the part is bolted down. It's securely fastened to the table. We basically got 3 points of contact here. So, I got 1 point up here in the front with the machinist jack or planer jack up underneath that clamps straight down through the table. Then we have 2 points clamped back here in the back side, and even though it's resting on just one piece, because it's so long and so wide, I'm counting this as basically 2 points of contact, and that's got me my 3 points that I need. So 3 points of contact, and you've got a tripod basically very steady, very stable. I will just comment, hey, I put a couple blocks of wood up underneath here. I did that when I was working on it. If the jack came out or whatever, it wouldn't slam down on the table. It was just where it was slide loose, but I've left that in there. Just a little bit more on the comments here on the setup. I've got my radius dresser for my service grinder set up here. Not that I'm going to be cutting a radius, but I needed something to dress this wheel with. So this has got a diamond in it, and it just worked out that when I set it up like this, it was almost the same height as the shaft. So I've just got this bolted down to the table. I'm just going to leave it here. So if I need to redress, you know, I've got some gap here. I can come in here and easily come back over here and redress my wheel. That'll be the very first thing we do is just dress it, make sure we got a good, smooth, 100% contact going all the way around, grinding surface, and then we're going to come in here and start grinding. Let me move you around the view so you can see this a little bit different right here. Well, this is where everything's happening down here. Just a couple of comments here before we get started. First off, you'll notice I got this kind of taped up. There's a bearing right inside this, and I really didn't want to get any grinding dust up into my bearing because that could cause further problems down the road. So I basically just made a shield here. I went and found a 3/4 inch washer, slid it over the shaft, and I just took some duct tape and kind of taped it on there, and I let the duct tape kind of come down here onto the shaft itself. So that's going to hopefully keep the dust from getting up into that bearing and causing any problems back there. I'll also comment, you can't really see it, but up here in my 50 taper socket in the milling machine, because we're going to be running the milling machine, there's not going to be any tooling in here. I just stuffed some rags up inside that again, just to keep any grinding dust from getting up inside that where it could cause some problems. We're going to lock our tables down in all but the one direction here, going back and forth. And we only need to grind. I just took a Sharpie pen and put a line on here. There's 2 seals that will actually, there's a boss that kind of fits up over this. There's 2 oil seals in here that keep the oil from leaking out. And I want to leave this area the original 3/4 of an inch diameter. And then basically from this line out, we want to grind it until it cleans up and we have a consistent diameter. When we measured this before, I think there was about 6 or 7 thousandths inch taper from large end to small end down here, and we basically just want to get all that the same diameter. And the other thing I'll mention here is, yes, this is going to be cylindrical grinding, and with cylindrical grinding you typically have your grinding wheel turning and you have your shaft turning. How am I going to turn the shaft? Well, the shaft turning is going to be all done manually, so I can just come down here. I got this little clutch rod. I got to make sure it's pushed in the right direction. But if I rotate the handle by hand, I'm rotating that shaft down there. So while this thing's feeding in, I can stand here, crank this, and I can still kind of see over here what's going on. When my grinder gets up to that mark, I'll knock my auto feed out of the table. But I'll just be sitting here turning this by hand to actually get the cylindrical grinding action going on. We'll just use the gearbox here to actually produce that. You know, if I was going to be doing a lot of this, you know, you could actually do some gearing from the out feed or the feed on the table here up to the handle where it would automatically feed. But hey, this is a one-time quick job. I'm just going to feed it by hand. So I think we're ready. Let's get in here. We're going to dress the wheel and start grinding this part. I'm going to go ahead and turn the milling machine on, turn the grinder on, and we're going to raise the table up. Let's see, I got my table locked in so it can't move in and out. And we're going to bring our grinder up here. Until we just touch off. I think we just touched a little bit. I saw a spark. And now here's some grinding going on. I'm going to come up just a little bit more. About 3 or 4 thou. And I think we got a pretty good finish on there, but I'm going to just do about another thou just to be on the safe side. All right, come over here to our part. And I know that my largest diameter is back here in the back, so I'm going to touch off there. I'm just going to, it's going to take a little bit of a contortionist act here because I'm going to have to bend this and raise the table at the same time. Hopefully I'm not in the camera. I saw a few sparks coming off there. I'm going to feed my table now. I'm going to slow that feed rate down. We'll slow it down to the 1/2 inch per minute, which is the slowest rate that I got. All right, we're going to go back into the depth of cut here. About right there. I'm going to feed my table down about 1 thou, or up about 1 thou rather. And I got my table feeding out. All right, so let me show you where we're at here. I've come in here and it's not quite cleaning up everywhere on this yet, but I found some areas that I could measure diameters out here toward this end and toward this end. I got it's got good contact all the way across here. On the back side, it's got a couple of gaps in there. And what I found out is that I've got about a 3/1000 taper going on here. And what that means is that this is up just a little bit in the front. So to fix that, what I need to do is I need to drop it down about half of that diameter that the difference in diameter. So I need to drop this, the end of this down by, I think, 1.5 thou. It may actually have to come a little bit more than that because my pivot point is actually way back here at the back, but we're going to start there and see. So I'm just going to loosen up my bolt down here on the jack, and I got the indicator on here. That's a 1/2 thou, 1 thou, 1.5 thou, and we'll take a light pass through there, measure it again, and see if we need to make another adjustment. But hopefully we're going to get this thing running perfectly straight, looking at the actual diameters down here where we're cutting. So let's take the indicator off and make another pass and see where we're at. All right, we should be making a light pass here. Let's engage our feed and come on out, and got to make a pass or two to probably get it to clean up all the way to the end after that adjustment. And we'll take another measurement and see where we're at. All right, guys, I think that we are in good shape. Let me come in here. I'm going to measure this. I don't know if you can see the micrometer or not. Let me pull it off of there. So we're right on 730 thousandths, right on the 5, dead on. And we come over here on the end, and we're maybe just a few tenths under on the end, but it's really, really close. It's plenty close enough for what I'm doing. So we are right at 730. We had to take about 20 thousandths total off the diameter to get this thing true. And part of that was because of me having to futz around with it to get this thing where I got the taper out. And I want to back up and correct myself on something there. So let's back up here. When we made that first pass, if you remember, I don't remember the exact number, I think it was 3.5 thousandths difference between here and here. And I came in and I said that we would need to drop it half the diameter differences, which was about 1.5 thou, if I remember right. So maybe it was 3 thousandths that we were taper that we had in here. I was on the right track, but I wasn't doing my math right, because remember we talked earlier about pivot points and where things are actually moving from. Well, that would have been right if my pivot point had been here. I needed to take half of the diameter out of it. But the problem is that my pivot point is way back here. So I measured in here, and it was about 1 inch between the two measurements before I could get my micrometer in there. It's actually about 1.25 inches, but because of where the micrometer was fitting, it was about 1 inch between the two measurements. Okay? If I measure from the end down here to the pivot point, it's about 29 inches. So you have to multiply this in, because again, we're pivoting down here to get a 3 thousandths taper in over 1 inch. You have to multiply that times 29. So again, we had 0.003. That was our difference in diameters, okay? We multiply that times 29, you get 87 thousandths. We need to take half of that, divided by 2. So instead of dropping it down 1.5 thou like I did, I actually need to drop it down 43.5 thousandths. And after I made a couple of adjustments and realized this isn't working out, I'd stopped the camera by then because I was scratching my head and thinking about things. It finally dawned on me, and by then I'd made a couple of adjustments and I was able to do that same math that I just did on the actual differences. I think we were down to about a 2 thousandths taper then, and I dialed it in, and presto, it came out, you know, within probably 2 or 3 tenths, which is plenty within the tolerance of where I'm after. So again, remember where you're pivoting from. That's a big multiplier in this case. Now, next question I know some of you guys are going to ask, well, you swept this thing over here and got it square. How come it needed to drop down 43.5 thousandths? Well, I don't have a good answer for that. I've got a couple of theories. Well, number one, I'm working off of a machine surface that goes up on this end down here. I'm not 100% guaranteed that this surface is perfectly in square with the shaft. It should be, and it probably is. More than likely, though, what's going on is when I was measuring this edge down here, I had the whole table moved in. And this whole thing's heavy. This thing is really heavy. And it was all sitting right over the saddle, okay? And when I wheeled this thing out this far, you know, almost 3 feet, I've got a lot of weight out here. This is an old machine, and quite honestly, it has a lot of wear in it. Now, I can still make very good parts on it. It still can do what I do, but you have to kind of take that into consideration. And I'm sure that what happened is when I brought the weight out here, it basically, because of the slop in the saddle there, it dropped down. And when I started grinding, what I had to do is I had to actually compensate for that slop in my table, and I was able to calculate that out using those measurements. In the end, no harm, no foul. We hit our mark. We got it where it needs to be, but you know, probably should have done a little bit more thinking about this ahead of time. As far as calculating that slop in the table, I don't really know how I could do that except basically going in there, doing what I did, getting it as close as I could, trying it out, and then make your adjustments from there. Fortunately, on this, I really wasn't trying to hit a particular number. I was just trying to get it straight and completely cleaned up. And because I have the liberty here that I'm going to have to actually adjust the pulley that goes on here, and I'm just going to make the pulley where it fits this. So I have that luxury in this case. You know, if this was a production job and we were going by a standard, you know, that would not be an acceptable way of doing this. But in a repair situation, my goal is to just get this thing right, and then I can make my pulley fit whatever this number is. But at the end of the day, job accomplished. We got things done. We were able to do cylindrical grinding on the horizontal milling machine using a tool post grinder. So kind of a strange combination, kind of a strange approach, but hey, you work with what you got. This is what I have, and so we made do with what we had, and we got the job done. So I'm gonna go ahead and pull this thing off. I'm not gonna bother you guys showing that on video, and we're just gonna put it back over on the bench. Gonna come back later on, we're gonna make the pulley. I won't put this back in the machine until I get the pulley where it fits just right, and then we can put it all back together. But fun little setup. I kind of enjoyed this job. You had to think outside the box to figure out how to do a job like this. Again, using the tools you got, using the equipment you got to get the job done. And I'm sure that I'm going to get a lot of people say, well, wouldn't it have been better to have used this, or wouldn't it have been better to use that, or wouldn't it have been better to go about it a different way? And you know, I'm sure you get 10 people in a room, you're going to come up with 10 different solutions to the problem. At the end of the day, it really doesn't matter how you get there. All that matters is that you get there. We got there with this setup. Was there maybe a better way of doing it? Possibly. Was there a better machine to have done this on? I'm quite sure. But at the end of the day, we got it done with what we had in the shop. Mission accomplished. Well, there you go, guys. That's going to be a wrap on this episode. I hope you enjoyed this. I know I did. This is the kind of stuff I like. I like having a challenge, a problem, and having to figure it out. And I like it when I come up with a kind of a wacky way of doing things. This is a lot of fun. So anyway, thanks for watching, guys. As always, if you haven't already, please subscribe to the channel and give me some thumbs up, leave me some comments, and we'll talk to you later. Thanks.